Hi students, welcome to Smartiq online classes. So today's class we'll see about three-dimensional geometry. We'll see some concepts, basic concepts in three-dimensional geometry and some problems that are expected to come in board exam, right? So let us see that. So what are the basic concepts in three-dimensional geometry? In three-dimensional geometry we have equation of line. What do you mean by equation of line? Is R equal to, R means a vector, it's a position vector, is equal to ABC. ABC is a column matrix here. Remember, column matrices are treated as vectors. So when you go to engineering, all the vectors you always handle using matrices. So any column matrix is called as a vector, right? So I have written, that's why I have written like this. So normally we write like this: A I cap plus B j cap C k cap. This is a point on the line, plus lambda, some constant, times another column vector di cap plus e j cap plus f k cap. This is called as a direction of the line. So every line in 3D will have a direction, and we have some point, reference point. There are actually infinite points on the line. We will take one point as a reference point. That point is ABC. It's a position vector. What do you mean by position vector? Position vector is a vector joining to origin, a point and origin. Suppose P is a point in the space. If you join that point P to origin, we get a position vector. So basically position vector is virtually called as a point. And there is a direction. Direction has a vector. That vector is di plus ej plus f into k cap. So this is the equation of line. So equation of line, this is called as a vector form. This is called as a matrix or parametric form. Okay. So this is called as a vector form. So how will you write in a vector form? R is a vector A plus lambda times some direction D. This is the equation of the line. This equation of line can be written in Cartesian form like this. This is called symmetric form. X minus A by first direction, component of direction D, y minus b by component of y axis, and similarly z minus c by f. This is also called as symmetric form. So this is called symmetric form of the line. This is most commonly used because a lot of problems can be easily solved when you use symmetric form, right? Where x naught, y naught, z naught is the point on the line, and these denominators actually represent what? Direction of the line. They are called direction ratios. So any line will have a direction vector. Say suppose he has 2i plus 3j plus 4k. This is the direction of the line. This 2, 3, 4 are called DRs, direction ratios. If 2, 3, 4 are direction ratios, minus 2, minus 3, minus 4 are proportional to these ratios, they are also called direction ratios. Similarly 4, 6, 8, they are also called direction ratios. Whatever you multiply to these numbers, a constant number k, still it will be direction ratios. What do you mean by direction? Cosines. Cosines means you take the numbers and divide by their magnitude of this factor. So what is magnitude of this factor? Root of 4 plus 9 plus 16, 13 plus 16, 29. So 2 by root 29 plus minus 3 by root 29 plus minus 4 by root 29. These are called direction cosines, because the property of direction cosines is what? Sum of the squares is 1, right? So this is the symmetric form of line. After line, we usually study equation of plane in 3D. The equation of plane passing through a point x naught, y naught, z naught is of this form: a into x minus x naught plus b into y minus y naught plus c into z minus z naught is equal to 0. So just simplifying this, you can write that plane equation in this form. This is the most general equation of plane in Cartesian form. Ax plus by plus cz plus d is 0. Normally, how will you write a line in 2D, two-dimensional geometry? In two-dimensional geometry, you will write the line like this, right? Ax plus by plus c is 0. Likewise, in three-dimensional geometry, you write the plane as ax plus by plus cz plus some d is equal to 0. But what is this importance of this coefficients of xyz ABC. This vector ai cap plus bj cap plus ck cap is actually normal vector to the plane. This is very important. Every plane has a unique direction of the normal vector. So if I draw a plane here and put a pen like this, then this is a normal. This is out of the paper or board, whatever it may be. So always the normal vector will be out of the board or inside the board. Inside the board means negative of n cap, and negative of n. Outside the board means just n. So every plane has a unique normal direction, right? And that direction is given by the coefficients of x, y, z. Skew lines. What do you mean by skew lines? In two-dimensional space, suppose if you take this board, if you draw two lines, they might intersect. So they are intersecting here. If I draw two lines, they can be parallel, they are not intersecting. So in two-dimensional space, if I give you two lines, either they should intersect or they should be parallel, right? But in three-dimensional space, the lines can intersect as usual. They can be parallel. Now they can be skew. So this line, dotted line, and this thicker line are not intersecting. Just imagine in 3D. So if you imagine in 3D, these are called skew lines. Skew lines are basically they do not intersect and they are not at all parallel. They are not parallel to, right? So neither intersecting nor parallel. So those are called skew lines in 3D geometry. So for skew lines, what is important is the shortest distance. So let us consider two lines L1 are equal to A1 plus lambda B1. This is a vector form of line. What is A1 here? A1 is a point on first line. What is B1? B1 is direction of first line. Similarly, L2 is A2 plus mu times of B2. B2 is direction of second line. A2 is passing through a point on second line. The formula is this shortest distance formula. There is a derivation also. I will do that in the regular class. Shortest distance formula is A2 minus A1. That is the vector. So if I have skew lines like this is dotted, assume. This is a point P. This is a point Q. This vector PQ is a line of shortest distance. That vector PQ is given by A2 minus A1. And the direction of this vector is actually, this vector, if you observe, PQ vector is perpendicular to each of the lines. In vector algebra, which is the vector perpendicular to both the vectors cross product, right? So if I give you two vectors in the plane, say this is A and this is B, what is the vector perpendicular to both? It is out of the board. That is vector is A cross B. So that is why it is B1 cross B2. So the shortest distance formula is this PQ vector dot directions cross product vector, that is B1 and B2, by modulus of B1 cross B2. So I can write like this: A2 minus A1 dot B1 cross B2 cap, unit vector, because this ratio is unit vector. What is the reason for modulus symbol? Because dot product can be negative or positive, but shortest distance is always positive. So this is the formula, right? So let us see some interesting problems related to 3D geometry, which are more of conceptual nature. You will get some conceptual clarity. Okay. The first question is, find the image of the point 163. You need to find the image of this point with respect to this line. This line is in which form? Symmetric form. X minus x by 1 is y minus 1 by 2 is z minus 2 by 3. So this is called as symmetric form of line. We need to find the image. So basically the diagram is this. It is like this. 163 is here. When you take image, it is like this. So this point P is required to be found, and this is 90 degrees, right? Actually 163 is not on this line. That actually you need to check before itself. How will you check whether this point lies on this line? Put x is 1, 1 by 1, 1. Put y is 6, 6 minus 1, 5 by 2. This 1 and 5 by 2 can never be equal. So this point is not on the line. So it is somewhere here, like this diagram. And this is called foot of perpendicular, Q. Now, what is the use of symmetric form? Any point on this line can be written like this. Assume it is P. all the three ratios you call it as t, then you will get x is t, y is 2t plus 1, so cross multiply and add 1, whereas z is 3t plus 2. So any point q on the line I can take it as t arbitrary point, this is because t is a parameter, 3t plus 2, this is a point q I am choosing, right? So this point q is this, okay. Why? What is the use? Yes, because I don't know what is q, I cannot tell you what is q in numbers, I can use only parametric form. What is the use of parametric form? Somehow we will find t to get exactly what is that point. How will you find that t? If you call this point, given point as aq vector, what is, if you join 2 points in space, what do you call that? Vectors. If they are provided they are at a finite distance, okay. So basically what is a vector? Vector definition is a directed line segment. And what do you mean by line segment? Segment is a finite line segment is of finite length, okay. So aq is position vector of q, that is oq, minus position vector of OA. So basically we subtract q points minus a point. So t minus 1 I cap t minus 1, okay. So I am just writing a here itself, 163. So t minus 1, 2t plus 1 minus 6, that is 2t minus 5 j, 3t minus 1 k. So this is the vector aq. This vector aq from the diagram is perpendicular to what? The line. But every line will have what? Direction. Now what is the direction of the line? This denominators comes into the picture now. So this direction of line is I cap plus 2 j cap plus 3 k cap. This is the direction vector of the line. Now this aq vector is perpendicular to this. What do you mean by two vectors perpendicular? Their dot product is 0 because cos theta is 0, cos 90 is 0, okay. So now we write aq vector dot with I cap plus 2 j cap plus 3 k cap is equal to 0. How will you take dot product? Take the corresponding components, sum of the products, okay. So t minus 1 into 1, so t minus 1 plus 2t minus 5 into 2 plus 3t minus 1 into 3, this should be 0 because this is the dot product, okay. So let us continue the next slide. So if you just simplify this, t minus 1, so I will get t minus 1, then 2t minus 5 into 2 is 4t minus 10, so plus 4t minus 10, okay, and 9t minus 3 plus 90 minus 3 is equal to 0. So this is plus. So if you just simplify 5t and 90, 14t minus 11 minus 3 minus 14. So t is 1. So basically the parameter we have found as 1. And how did you find the parameter? By using the dot product of direction of the line and the vector aq. So now what is point q? So now you know the parametric form of point q. So substitute t is 1. So 1, 3, 5. So that is the point. So q is just 1, 3, 5. So this is the point. So now let me draw the diagram once again. So this is 163, which is A, and this is Q, 1, 3, 5, correct? This is the image P. What do you mean by image? Whatever the distance, suppose a person is starting at A, he is reaching at Q, that distance he should cover from Q to the point P. So basically this distance is same as this distance. Distances are equal, what do you call Q as? Midpoint. So basically Q is midpoint of AP. Midpoint of AP. And how will you find midpoint? Same formula as in coordinate geometry, 2D geometry. x1 plus x2 by 2, y1 plus y2 by 2. But in 3D geometry it is x1 plus x2 by 2, y1 plus y2 by 2. This is z coordinate, z1 plus z2 by 2. This is the formula of midpoint. Now let us assume P as alpha, beta, gamma. So what is the midpoint of alpha, beta, gamma in 163? it is what? Q. So alpha plus 1 by 2 x coordinate, beta plus 6 by 2 y coordinate, gamma plus 3 by 2. This should be equal to 1, 3, 5. When two coordinates are equal, corresponding x and y coordinate should be equal. So just equate, we will get alpha plus 1 is 2, beta plus 6 is 6, and gamma plus 3 is 10, right? So alpha is 1, beta is 0, gamma is 7. So what is the point B? It is 1, 0, 7. This is the answer for image. So whenever the question is asked image of a point with respect to line, make the line to symmetric form. If it is already given, well and good. After symmetry form, take a parameter t, take some random point q, take the aq vector, take the dot product with direction of the line, then you will get what? T. When you get t, you will get q. Then use midpoint formula, you will get the image, right? Find the shortest distance between the lines x minus 1 by 2, y minus 2 by 3, z minus 3 by 4, x minus 2 by 3, y minus this one, and also find the equation of line of shortest distance. Very important question, especially this part is very important. Shortest distance everyone can find because we have a formula for that, right? So first let us find the shortest distance. So first part is to find shortest distance. So what is the formula we have written? A2 minus A1 dot B1 cross B2 divided by mod B1 cross B2. What is B1 B2? B1 is direction of first line. What is direction? 2 I cap plus 3 j cap plus 4 k cap. This is the direction of B1. B2 is basically 3 I cap plus 4 j cap plus 5 k cap. Once you know B1 and B2, let us find the cross product. Then what you will get? Determinant I, j, k. So this is a way to find cross product, right? 2, 3, 4, 3, 4, 5. So just evaluate it. What you will get? I into, so 15 minus 16 minus 1. So I am just doing the determinant evaluation. Minus j into 10 minus 12 minus 2 plus k into 8 minus 9 minus 1. So it is minus I cap plus 2 j cap minus k cap. This is the direction of what? The cross product. That means if I have a skew lines like this PQ direction is this direction. This is the PQ is called line of shortest distance. Line of shortest distance. And that line has a direction given by this. So has direction given by minus I cap plus 2j minus k. Now we know the direction B1 cross B2. What is A2 minus A1? What is A1? A1 is basically the point on the line 1. What is the point? 1, 2, 3. X minus X naught. What is X naught here? 1. Y naught is 2. Z naught is 3. So 1, 2, 3. And what is A2? 2, 4, 5. Is it not? So 2, 4, 5. So just subtract A1 and A2 or A2 minus A1 because anyway mod is there. So I get a vector. What is that vector? So you subtract like this: 2 minus 1 I cap plus 2 j cap plus 2 k cap. This one. Okay. Now let us find the shortest distance. So let us use the formula. So just take dot product of I plus 2 plus 2k. We'll continue in the next slide. Shortest distance is I plus 2j plus 2k dot with direction. What is the direction you got? Minus I plus 2j minus k. Minus I plus 2j minus k divided by square root of magnitude. What is the magnitude? 1 plus 4 plus 1, 6 with mod. Now take the dot product, corresponding sum of the products. So minus 1 plus 4, correct, minus 2 divided by root 6. It is nothing but 1 by root 6. So this is the shortest distance. So that is just formula based. But how to find equation of line of shortest distance? That is important now. Okay. Let us take the point P. we don't know what is point P basically. This point P we didn't find, this point Q also we didn't find, but shortest distance PQ we know. It is something like this. When I give you 2 points P and Q, distance between them is very easy to find, is it not? But when I give you distance, if I ask you what are those 2 points, then there is no answer, right? There are infinite answers, because if I give you a distance of 6 centimeters, there are a lot of pairs of points such that their distance between them is 6 centimeters. So indirectly I am asking the same question. Since the distance is 1 by root 6, does it mean we can find P and Q? No, we cannot find. So, but how to find P and Q? We know the direction of PQ, that is okay, but we need either P or Q, or both also, no problem. Then we can find the equation of line, right? Because we know denominators already. The denominator is this only, minus I plus 2j minus k. If I know at least P or Q, then we can find the equation of line. So what we do now is we will take the parametric form of this sign, this. Call this as some t. So let us take x minus 1 by 2, or the point of P is x minus 1 by 2 means 2t plus 1. So I am just calling it as t. So this is taken as t, whereas this is taken as s. So 2t plus 1, 3t plus 2, okay. So 3t plus 2, and then 4t plus 3. So this is point P, any arbitrary. But I am assuming we need to find t now. We will find it. Q is, don't take s, don't take t here, take some variable s. 3s plus 2, 4s plus 4, 3s plus 2, 4s plus 4, okay, and then 5s plus 5, 5s plus 5. This is the point Q. Now let us find PQ vector. So what is a PQ vector? Q vector minus P vector. So just subtract 3s plus 2 minus 2t minus 1, that is 3s minus 2t plus 1 I cap, this is a vector, right, I cap, plus 4s minus 3t plus 2 j cap, correct, and the last one is 5s plus 5s plus 4t, 5s minus, sorry, this is minus 4t plus 2 k cap. This is the direction of PQ. Why I am finding direction of PQ? What is the use of direction of PQ? The direction of PQ is perpendicular to both line 1 and line 2, and the direction of PQ is basically minus 1 to minus 1, okay. So we will get the ratios. So basically the direction is parallel to, this is parallel to minus I cap plus 2 j cap minus k cap. What do you mean by vectors? Two vectors parallel, the corresponding component ratios must be same. So let me equate ratio 3s minus 2t plus 1. Let us go to the next slide. 3s minus 2t plus 1 divided by, what is the component here? Minus 1 should be equal to, what is the component here? 4s minus 3t plus 2, right? 4s minus 3t plus 2 divided by, what is the component here? 2 is equal to, what is the third component? 5s minus 4t plus 2, right? 5s minus 4t plus 2 divided by, what is the component? Again minus 1. You cross multiply these two, then you will get two equations in two unknowns. Solve them, you will get s sin t. So let us cross multiply the first part. 6s minus 4t plus 2 is equal to minus 4s plus 3t minus 2. So it is 10s minus 7t is equal to minus 4. This is one equation you got, correct. Let us cross multiply these two. It is minus 4s plus 3t minus 2 is equal to 10s minus 8t plus 4. So the equation what you get is 14s minus 11t is equal to minus 6. Removing 2, so I am writing that equation here. 7s minus 11 by 2t is equal to minus 3. These two are the equations we got. Two linear equations in two variables, easily we can solve. Then you will get what? S sin t. So just solve this, then you will get S value and T value. Okay. So how to solve this? Use method of elimination or whatever it may be. Once you get S or T, suppose I got T, you substitute this T value where? You substitute the T value in this point P. That means I know the point P. And you got S also, substitute here, then you are getting what? Q. Since you know P and Q, equation of line is very easy. So assuming that we have already solved, so I am not solving this simple thing here. So suppose you know already T, then equation of line is x minus, suppose we are taking point P as a reference. You can take point Q also as a reference. Any point you can take because line contains infinite points. So x minus of 2t plus 1 divided by the direction ratio of the first minus 1 should be equal to y minus of this one 3t plus 2 divided by 2, the direction ratio of the second component is z minus of, what is z minus of? 4t plus 3. I am taking point P as a reference here, divided by minus 1 again. This is the equation of line of, this is the line of shortest distance. So this is the way to find, because if you solve these two equations you will get the value of T, that you substitute here you will get the line of shortest distance. So this is the way to find line of shortest distance, right? This is a very important problem. Find the projection of the line in the plane x plus y plus z is 3. What do you mean by projection? So just a rough diagram here. There is a plane here. Plane is actually two-dimensional flat surface, right? There is a line. First, in these kind of questions, first check whether the line is parallel to the plane. When will be the line parallel to the plane? When the line direction is perpendicular to the normal to the plane. So what is the normal vector to the plane? NP, normal vector to the plane is components, x, y, z components are 1, 1, 1, coefficients, sorry. So it is I plus j plus k. This is the normal vector to the plane. And what is the direction of line DL? DL is 2i cap plus j cap minus 2 k cap. This is the direction of line. Check the dot product. So dot is DL dot NP is equal to 2 into 1 2 plus 1 minus 2 which is 1, which is not 0. So line is not parallel to the plane. If line is not parallel to the plane, then line should intersect the plane. So basically the line is looking like this now. And what is the point on the line? X naught, y naught, z naught, 1 2 3. So 1 2 3 is the point on the line. This is a point on line. But is this point lying on the plane? No, because if you add all these three, x plus y plus z, what is x plus y plus z here? 6. But right side is given what in the plane? 3. So take the point outside the plane, that is how much? 1 2 3. This is a point. This is a point Q here. What do you mean by point Q? Q is actually meeting the plane. That means something like you have a pen and a paper. You pinch that paper with your pen. So your pen is the line and the pinched point is this thing, point Q. Okay. So the point Q is basically the hole you are making with the pen. How will you find that point Q is? You take the parametric form of the line 2t plus 1, t plus 2, 3 minus 2t. This is a parametric form. So basically I am equating this to t. The same thing what we have done in previous question. Assuming this is the point Q, this point Q is lying on what? The plane. What is the equation of plane? X plus y plus z is 3. When any point is lying on the plane, it should satisfy the equation of the plane. So add all these coordinates because x plus y plus z. So let me add 2t plus 1 plus t plus 2 plus 3 minus 2t is equal to 3. Correct? So if you simplify, this is 3t minus 2t, t, and 6, t plus 6 is 3. So t is minus 3. So this is the value of t. Substitute t value in this q. So I am getting q as, so what will be I am getting q? Q is t is minus 3 means minus 5, minus 3 means minus 1, minus 3 here means how much? 9. So this is the point q. So basically the point q is minus 5, minus 1 and 9. This is the point q. But I need the projection. So what we do is, from P you draw foot of perpendicular onto the plane. So if you draw the foot of perpendicular onto the plane, this QM, I will call that as M, is called the projection of this line on the plane. Okay. So QP's projection on the plane is QM. So what they are asking the question is, they want this QM line equation. If you project a line on a plane, what you will get? Line only, right? So that QP is a actually given line. You are projecting on the plane, and what line you are getting? QM. But you already know Q. What else you need to find to get the equation of line? Direction. How will you find the direction? I need to know M. M is foot of perpendicular. So let me continue in the next slide. M is foot of perpendicular from which point? That 1, 2, 3 on plane. So for this I am giving one formula, very important formula. The formula is this: alpha minus 1, the x coordinate, divided by the component coefficient of x 1 is equal to beta minus y coordinate 2 by the coefficient of y in the plane 1, gamma minus 3 divided by coefficient how much? 1 is equal to minus of, substitute 1, 2, 3 in the plane equation, 1 plus 2 plus 3, bringing 3 also left side, by squaring of components of plane, 1 square plus 1 square without any square root. So this is the basic formula of finding the foot of perpendicular from a point to the plane. So if the point is x1, y1, z1, and the plane equation is ax plus by plus cz is equal to, or plus d is 0, then alpha minus x1 by a, capital A, beta minus y1 by capital B, gamma minus z1 divided by capital C is minus of ax1 plus by1 plus cz1 plus d divided by a square plus b square plus c square. This is the formula. I am not writing that formula, but directly used it. Now let us solve this. So alpha minus 1 by 1 is beta minus 2 by 1 is equal to gamma minus 3 by 1 is minus of, this 3 cancel, 3 by 3 minus 1. Okay. So cross multiply, alpha is 0, beta is 1, and gamma is what? 2. So 0, 1, 2 is our M, that is the foot of perpendicular. So in the previous diagram, this M is 0, 1, 2. That's it. I got 2 points on the line. So what is the direction QM now? So I am just continuing here only. The direction QM is M point minus Q point. So M is what? 0, 1, 2. So subtract 5, 1 minus of minus 1, 2, 2 minus 9, minus 7. So 5, 2 and minus 7. So that is the direction. 5 I cap, what did you get here? 2 and minus 7. 2 j cap minus 7 k cap. This is the direction. So equation of projection is projection. So what is the projection of the line? So I am continuing here. Projection of line, given line in the plane, which plane? X plus y plus z is equal to 3 is given by x minus, take the point M or Q, whichever you want, doesn't matter now. So I am taking M, 0, 1, 2. So x minus 0 divided by, what is the direction ratio? 5, okay, is equal to my y minus 1 by 2, correct, 5, 2, and last one is z minus 2 by minus 7. 5, 2 minus 7, 0, 1, 2 is the point. So this is the answer for the projection. So this is a way to find the projection of the line on the plane, right? Let us discuss this question. This is a very conceptual question. Find the line of intersection of two planes. When two planes intersect, they meet in a line. So like pages of your book has a lot of pages. Treat each page as a line. Then the border of the book is called the line of intersection of all the planes. But if planes are parallel, they won't form a line. So whenever this question is asked, find the line of intersection of planes, first find whether they are parallel or not. So what is the normal vector for the first plane? It is I cap minus j cap plus 2 k cap. What is the normal vector for the second plane? It is 3 I cap plus j cap plus k cap. So are they parallel? Obviously no. If two planes are parallel, their normals should also be parallel. So that means they are planes intersecting, and two planes always intersect in a line. How will you solve that is, what we do is, see, I'll just draw a rough diagram here. Suppose this is the plane, first plane P1, and this is the second plane P2. This is the suppose Mn. This Mn is what? Line of intersection of two planes. So there is a normal to this plane N1, there is a normal to this plane N2. If you take the cross product of this N1 and N2, you will get the direction of the line. That is the concept. So just imagine you take two pages of your book, take the normal of first page, take the normal of second page, take the cross product of those two normals. That cross product of those two normals should be your border of the book. And what is the border of the book? Direction of the line. Okay. So direction of the line is given by N1 cross N2 of the planes. So let us find this determinant I, J, K. So this is the direction of the line DL. What is the components? 1, minus 1, 2, 3, 1, 1. So let us evaluate this. Then you will get I into, okay, minus 1, minus 2, minus 3, minus J into, okay, 1 minus 6, minus 5, plus K into, right, 1 minus of minus 3, 4. So this minus 3 I cap plus 5 j cap plus 4 k cap is the direction of the line. Now you know direction of the line, that means you know the denominators of the symmetric form. What else you need to know? The point on the line. That is very easy to find. If you just observe this diagram, any point common to both the planes lies on the line because they are intersecting in a line. So this point, all these points are common to both the planes, which is nothing but those points lie on the line. So I will tell you a simple technique. What we do is, let us go to the next slide. So in this two plane equations, let us substitute z is 0. So put z is 0 here. So when z is 0, just randomly I am taking z is 0. Why z is 0? Just take some value. Z is 1 also can take it. So x plus y plus 0 minus 5. 0 equal to 5. So what is the equation you got? X minus y is 5. Also put z is 0 in the second plane. So 3x plus y plus 0 minus 6 is 0, that is 6. Now you have two linear equations in two variables, right? Solve them. So add both, you will get 4x is 11. So x is 11 by 4. When x is 11 by 4, substitute in first equation, y will be 11 by 4 minus 5, that is minus 9 by 4. And what is that? 0. What exactly we are doing here? This point, x coordinate is 11 by 4, y coordinate is minus 9 by 4, 0. This point is lies on plane 1 and plane 2, correct? When this point is lying on plane 1 and plane 2, what do you mean? What can you infer from that? Implies that point lies on line, because any point common to both the planes lies on the line. That's it. So we got a point. So equation of line is x minus 11 by 4 divided by, so what is the direction ratio? We got minus 3, 5, 4, right? So minus 3, and y minus or minus 9 by 4. 9 by 4 divided by 5 is equal to z minus 0 divided by 4. So this is the answer for the line of intersection of two planes. This line is in which form? Symmetric form. You can convert this to vector form, that doesn't matter. That easily you can do it. What is the vector here? Minus 3i cap plus 5j cap plus 4k cap. What is the point here? 11 by 4, position vector, 11 by 4i minus 9 by 4j plus 0k cap, right? So let us see the last problem in 3D geometry. We are actually given two pairs of planes. This is first plane P1. This is second pair P2. Question is, if these two planes, these two planes are actually meeting in a line. So this is P1 and P2, two planes. P3 and P4 are two planes. These two planes meet in a line, like in previous question. These two planes also meet in a line. So let this line is called L1. Let this line is called L2. It's given that L1 is perpendicular to L2. When L1 is perpendicular to L2, we have to prove that this condition should be proved. We use the same method, but here no need to find the point. We are actually not interested in finding the point on the line 1 and line 2. What is important? Direction of line 1 and direction of line 2. So let us write plane 1, plane 2 equations in proper form. X minus ay plus 0z is equal to b, correct? And the plane P2 is, this is P1. Plane P2 is 0x minus cy plus z is equal to d. This is plane P2. Why I am writing in this form? Can you guess? It is just we are finding the normal vector for each plane. So what is n1 vector for this plane? First plane, it is I cap minus a j cap plus 0 into k cap, correct? N2 is 0 I cap, correct, minus c j cap plus k cap. Now when these two planes meet in a line, from the previous problem, what is the direction of the line? Cross product of n1 and n2 is the direction of the line, is direction of the line, correct? So let us find the cross product. It is I j k, component 1 minus a 0, component 0 minus c 1. So let us evaluate this determinant. I into minus c minus 0 minus j into, correct, 1 plus k into I am sorry, I into minus a, this is minus a, minus j into 1 plus k into minus c. So basically I will just go to the next slide. dl1 direction is nothing but minus ai cap, okay, minus ai cap minus j cap, and what we got last one, minus c k cap. This is the direction of first line. What is first line? First line is basically the line formed by meeting of these two planes. Can you guess what is the direction of the second line? It's very easy, right? Instead of small a, what you have here? Capital A. Instead of small b, capital B. Small c means capital C, small d. So wherever small letters are there, replaced with their corresponding capital letters. So direction of line 2 is minus capital A I cap minus j cap minus capital C k cap. These two lines are given what? Perpendicular. When two lines are perpendicular, dot product is 0. So dl1 dot dl2 is 0. So take the dot product. Minus small a into minus capital A, minus 1 into minus 1 plus 1, minus c into minus capital C plus c capital C is 0. So finally we have arrived at condition. This is the condition when two lines are perpendicular and those two lines are obtained from these planes. So these are the problems. I hope you enjoyed these problems. Very conceptual, okay? So just go through it once. Any doubt you can always comment in the channel, okay? So let me give you the last literature review. These are the R.D. Sharma book. As usual, you need to follow exemplar problems. There's one good book by Singh, Vectors in 3D Geometry, especially useful for JEE Mains and KCT. So if you are interested, you can follow this book for JEE and KCT. And you can take these problems for assignment. The first question is angle between the lines whose direction ratios are given. Direction ratios mean they are actually vectors. Find the angle between line and a plane. This is very important. How will you find angle between line and a plane? You find the angle between the line direction and the normal and just think what to do. Whether we have to take sine inverse or cos inverse, that you just think of it. And this is another question. So please try these questions, right? Thank you so much.